Hello and welcome back to another Walking Talking Mark. This is a C4 Walking Talking Mark, and this was actually a subscriber request. So shout out to Layla for requesting June 2006 C4. So let's get started. I'm going to do section A in this video. Then we'll do section B. Okay. So figure 1 shows part of the graph of y equals sine x minus root 3 cos x. Express that in the form of r sine, yep. Hence write down the turning point. Okay, cool. So r sine x minus alpha is got to equal sine x minus root 3 cos x. Now, the formula, the multiple angle formula? No, compound angle formula for sine is sine cos sine, isn't it? Sine x cos alpha minus sine alpha cos x. You do not, no, yes, you do get these in your formula booklet. You do get those. What you don't get is double angle, but you can always derive the double angle from this one. Okay, so I've expanded that and left that same. Now we're going to compare the coefficients. So if I look at the sine x bit, I can see that to make those two parts equal, r cos alpha is going to have to equal 1, because the coefficient of that is 1. And if I compare the cos bit, I can see that minus r sine alpha is going to have to equal minus root 3. Okay, so I don't need the minus then. So I'm going to draw a little diagram. So r is the hypotenuse. Cos alpha is the adjacent over the hypotenuse, which means the adjacent needs to be 1. And sine alpha is the opposite over the hypotenuse, which means the opposite must be root 3. So tan of alpha is therefore opposite over adjacent, so that's root 3 over 1. So alpha is the inverse tan of root 3, which I believe is 60 degrees, pi over 3. It is, right? Root 3, 60, yeah. Okay. And I can get r as well from Pythagoras. Which is 2. So I know that the answer is 2 sine x minus pi over 3. And then I'm just going to ask myself, does that make sense looking at my picture? Does this graph look like a sine graph that has been stretched by a multiple of 2 in this direction? Yeah, could be. And does it look like it has been translated, pi over 3 to the right? Yeah, that's feasible. It's definitely feasible. So what's the turning point? Well, it's the maximum point of this thing here. The maximum point. What is the maximum point of this? Well, for it to... The maximum value of sine, we know, is 1. If I double the maximum value of sine, I'm going to get 2. So the y-coordinate is definitely going to be 2. The maximum y-coordinate is definitely 2. because normally the maximum is 1. This has been stretched by a scale factor 2. Okay, what value of x would lead to a y value of 2? So that's like saying I need sine of x minus pi over 3 to equal 1. And sine normally equals 1 at pi over 2, 90 degrees. So that means that x minus pi over 3 equals pi over 2. So now x will equal pi over 2, but it's been shifted a little bit. It's been shifted by this pi over 3. So I add that on, which is, that's 3 out of 6. So there's 5 pi out of 6. 3/6 plus 2/6. Yeah. So it is 5 pi by 6 and 2. Let me check. It makes sense. Yeah, it's pi over 2 plus a little bit extra that's been shifted. Yeah, cool. Checking the mark scheme. Okay, so we're going to get B1 for finding r equals 2. You're going to get M1 for the tan line here. Tan line, A1 for pi over 3. It does allow degrees, interestingly. It really shouldn't, because it does tell you alpha is between 0 and pi over 2. M1 for using what? For x minus, using x minus their alpha equals pi over 2. Oh, this, M1 for that. A1 for that answer. Oops, you can't even see this. Sorry. And then B1 for the y coordinate. Yep. 6 marks. Okay. Question 2. Nice algebraic fraction. Given that this equals this, where a, b and c, find a, b and c. Okay, so partial fractions. And they gave you the format of it, which is quite nice of them. So you don't have to remember what the 3 different ones are. You just write it out. Okay. Right, well, we'll just solve this the way that we normally solve algebraic fractions. So I'm going to times everything here by 1 plus x squared, 1 minus 4x. And hopefully I have done that right. Okay, so let's say let x equal minus 1. This is an identity, by the way. It's always true. So let x equal minus 1. Put that into that. We're going to get 5 equals, that's going to disappear. That's going to disappear. This is going to give us 1 minus minus 4 is 5. 5b. So b is 1. And then let's say let x equal, what makes this disappear? A quarter? Yeah, x equals a quarter. We get a quarter squared is a 16th. Ugh, ugly. Times 2 is an 1/8. 3 and an 1/8. 25/8. 25/8 equals that disappears. This becomes 1 1/4 squared. 5/4 squared is 25/16. Okay, so C equals 2. Then we can just use any old number we like to find A. So let's just say let x equal 0. Why not? 3 equals 1 times 1 is A. 1 times 1 plus 2. Just subbing the B and the C into here with x is 0. So, oh, that looks like A is 0. Okay, fine, A is 0. That would probably make me a bit scared in the exam to realise that A is 0. Oh, wait. It's okay. Show that A is 0. Yeah, I think they know that you would be a bit scared in the exam if you found that, and that's why they put that there. Okay, cool. I found A, B, and C. Next part. Given that x is sufficiently small, okay, binomial expansion, find the first 3 terms of the binomial expansions of 1 plus x to the minus 2 and 1 minus 4x to the minus 1. Let's see if I can remember how to do this. 1 plus x to the minus 2 is approximately equal to, let's try and remember this formula. Does it start with 1? I think it starts with 1. Plus nx. Right, so that's minus 2x. Plus, is it nx squared over n? Come on, you can remember this. It's n. Oh, no, it's n minus 1. n minus 1 x squared over 2 factorial. How many terms? First 3 terms, so it's just that. Okay, which is 1 minus 2x plus 3x squared. Okay, and then I should write valid for mod x less than 1. And then 1 minus 4x to the minus 2, no, minus 1 is approximately equal to 1 plus nx plus n minus 1. Oh, x is 4. 4x. Then n minus 1 x squared over 2 factorial. So 1 minus 4x, 16x squared. Yeah, okay, 16x squared. 1 plus 4x. Wait. This is nx, so that should be plus. Because n is actually minus 4. It's a bit. Yeah, okay. N is minus 4. No, not n. X is minus 4x. That's what I'm trying to say. Valid for mod 4x is less than 1, so actually mod x is less than a quarter. Okay, now, so I did that, hence find the first 3 terms of that. Okay, I'll use the partial fractions, obviously. So, and what I actually want is, the a was 0, so what I'm finding is b is 1 over 1 plus x squared plus 2 over 1 minus 4x. okay, which is equal to, have that one, I just need to double that one, so I just need to have that one, plus double that one. Wait, this should say approximately equal to. Okay, so 1 plus 2 is 3, minus 2 plus 8 is 6. 3 plus 32 is that. Valid for, I have two here, I have this one and this one, so I have to go with the strictest one, which is that. Cool. Okay, let's look at the mark scheme. So we are going to get M1 for clearing the fractions, as they say. B1 for B equals 1. B1 for C equals 2. And E1 for A equals 0. It's an E because they gave you the answer already. M1 for the binomial sort of method, and A1 for the answer. Because it said in the question that x is sufficiently small, you don't need to say the valid bit, because it already told you it's sufficiently small. But I will always write the valid for, because I don't want to ever get out of that habit, because I want it to be second nature, because you don't want to lose that mark in the exam. Then just an A1 for this and don't get another method mark. Interesting. Then just an A1 for adding them together. No method mark. Whoops, you can't see that. Interesting. Yeah. Okay. Question 3. Given that sine theta plus alpha equals 2 sine theta, show that tan theta equals that, hence solve that equation. Okay. So sine theta plus alpha equals 2 sine theta. Okay, let's use the compound angle formula. So that's sine theta cos alpha plus sine alpha cos theta equals 2 sine theta. Okay, what I'm trying to get is tan. So if I'm trying to get tan, I should probably divide everything by sine. No. Divide everything by cos. Yeah, I need to divide everything by cos. Okay. Cos what though? Cos... I'm trying to get tan theta, so I should probably divide everything by cos theta. Okay. Divide by cos theta. Both sides, obviously. So that's going to give me tan theta cos alpha, and that's going to give me sine alpha, and that's going to give me 2 tan theta. Okay. I guess I will get the tans together. Like so. And then I will, you know what, I almost said sacrifice. I meant factorize. Sacrifice the tan. I actually prefer saying that. I'm going to start saying sacrifice instead of factorize. I decided. Okay, that makes that. And tan theta equals that. I believe that's what we wanted. Oh, no, it's not. So close. So close. What did I do wrong? can't I just... where's it wrong? How did I get 2 minus? Oh, I know why. That should be a minus. You probably spotted that and you think I'm stupid. Okay, so let's times this all by -1. It would have made more sense to take away this from both sides, to put it over here, instead of what I did. Yeah, that would have made a lot more sense. Oh well. Okay, so I got that answer. Hence solve the equation that equals. So basically I just need alpha to equal 40. So I just sub alpha equals 40, right? Tan theta equals sine of 40 over 2 minus cos of 40. Don't know that off by heart. Am I in degrees? Yes. Sine 40 over 2 minus cos 40. 0.52. It doesn't say exact value, does it? No. Say 521. And then let's inverse tan that. Shift tan answer. 27.5 degrees, we'll say. Oh, wait. Between 0 and 360, so there's obviously going to be another answer. Tan is just a periodic function, so I just need to add an extra 180 onto that to get my other answer. No need to draw a graph or do some hideous cast method thing. There we go. Lovely. Alright. Oh, 7 marks for that. That's nice. Let's look at the mark scheme. Okay. We get method 1 for using the compound angle formula. We get M1 for dividing by cos theta. We get M1 for collecting the terms in tan. Or sacrificing the tan. E1 for getting to the answer. M1 for subbing the 40. And then accuracy 1 for each of the 2 answers. Okay. Question 4. The number of bacteria in a colony is increasing at a rate that is proportional to the square root. This is differential equations. Okay. Proportional to the square root of the number of bacteria present. Form a differential equation relating x, the number of bacteria, to the time t. Okay. The number of bacteria is x. Okay, the number of bacteria in a colony is increasing at a rate of. Okay, the number of bacteria is increasing at a rate of. That means dx by dt. That is the rate. That is proportional to. So equals k times, is proportional to, means k times, the square root of the number of bacteria. Form a differential equation. Oh, so it's just that. That's not too bad. That's not too bad. We don't have to solve it or anything. That's just all we had to do. Part B. In another colony, the number of bacteria y after time t minutes is modelled by this differential equation. Find y. Oh, so basically solve it. basically solve it. Okay, so dy by dt is 10,000 over root y. Okay, so I'm going to separate these variables. So root y dy equals 10,000 dt. So what I've done is times both sides by root y and times both sides by dt, which doesn't actually make any mathematical sense because dt is not, a variable. It is something more symbolic than that. But we can put integral symbols and it solves all of those problems of questionable mathematics, and it's now valid. Okay, so now we're going to integrate both sides. Integrate this one, y to the power of half, so we raise the power, divide by the new power, and that's just a number. So when you integrate it, it becomes that t. And I should put a plus c somewhere. I'll put it there. Could have put it on the other side, it doesn't make a difference. Given that y equals 900 when t equals 0. So 2/3 of 900 to 3/2 has to equal c. What's that? 900, square root of 900 is 30. 30 cubed is a big number. And then times it by 2 and divide it by 3. So c is 18,000. Okay. So the actual equation, I should make this, I should actually write y equals rather than leaving it as this ugly thing. So y to 3/2 equals 30,000 t over 2, no, okay, 15,000 t plus 27,000. And then I should, I guess, square both sides and cube roots both sides. Maybe I should have found the c afterwards, so that it would be outside the bracket. Would that have been clever? Oh well. I'm just looking at the answer and I can't tell if my answer is right because they factorised it in some really weird way. Yeah, it is right. They factorised it like this. I think this is so ugly. They took out a factor of 1,500. Like that. I don't know why they think that that is nicer, but okay. What's next? Hence find the number of bacteria after 10 minutes. Is t in minutes? Yes, it is. I was worried it was in seconds, but it's okay. T equals 10. I just need to sub that in. Cube root of yeah, 1208. Wait. That's not the right answer. What did I do wrong? Oh, I missed a 0. I missed a 0. Thank you, whoever spotted that and was shouting it at the screen. That's the right answer. I'm going to round it to the nearest bacteria because that makes sense to me. You can't have a decimal of a bacteria, of a bacterium. Am I supposed to say bacterium? I don't know. Biologists can correct me. I'm sure Tamin knows. Okay, mark scheme. So, what? Where is it? M1 for writing dx by dt, even if you didn't know what to put afterwards. A1 for this side. And then M1 for separating the variables. A1 for this answer, even if you don't have plus C. B1 for finding the C. A1 for any correct expression for Y, however way you have factorised or not factorised it, however way you've done the powers, as long as it is correct. M1 for substituting t equals 10, and A1 for the answer. Yeah, correct answer only. Okay. Number 5. This paper seems really long. Oh. Last question of section A. Show that the integral of that is that. Gladly. So, integral of x e to the minus 2x dx. Okay, it's a product, which means that I'm going to use integration by parts. Generally speaking, when you've got a product, use integration by parts. Integration by parts is kind of like the opposite of the product rule. So yeah. Right. I need one of them to be differentiated. I need one of them to be integrated. Which one of these would I rather differentiate? Well, E makes no difference whether I differentiate it or integrate it. I'm going to get basically the same answer. Makes no difference. The X, however, if I differentiate it, it becomes just 1, which is very nice because 1 is a very basic number that cancels a lot of things out. If I integrated it, I would get an x squared over 2, which isn't as nice. So I'm definitely going to differentiate the X and integrate the E. Okay, du by dx is 1, v is minus a half e to the minus 2x. So this integral, let's just bracket that off so I can write equals uv minus integral v du by dx dx equals, did I have limits? Nope. Equals this. If I integrate this, I'm going to get plus a half e to the minus 2x plus c equals, I could factorise this. E to the minus 2x minus x over 2 plus a half plus c. So let's say a half e to the minus 2x, 1 minus x. Oh yay, I love it when the answer is wrong. Okay, what did I do wrong? Tell me. What did I do wrong? G by dx v uv minus integral v du by dx. Oh. What? Why didn't I put... I must have been looking at that one. Okay, so... I need to slip in a minus half there. Sorry about that. Okay. So that becomes plus... No, it becomes minus once I integrate it, and that becomes quarter. Okay. Like that. So let's take a quarter out. Let's double that. That's minus. So that's that. What a shambles. But oh well. I got the right answer in the end. That's what matters, right? Okay, good. Now we have a vase which is made in the shape of the volume of the revolution of this curve about the x-axis between 0 and 2. Show that the volume of revolution is this. Okay. Now, if I remember correctly, volume of revolution is the integral of pi times y squared between the two limits, in this case 0 and 2. Okay, so integral between 0 and 2 of this equation squared. What would that be if I squared it? That would just become x, and that would become e to the minus 2x. Okay, I see where they're going with this. Because that's actually the thing from earlier. So I already know the integral of that. Well, apart from the limits. Is it exactly the same, or did they change it at all? Let me just check. X to the e to the minus 2x, x e to the minus 2x. Yeah, it's exactly the same. Okay, so I already know the integral of that. Let's just put in the limits then. Okay. Let's put the quarter outside because it's in my way. E to the minus 4. Sorry, minus e to the minus 4. Maybe I should put the minus outside. No, never mind. Times 5. Can I put that here? Okay, you know what? I'm putting the minus outside. I don't care. Minus e to the 0 is 1. And that's 1. So that's that. Okay. Which equals the answer except negative. Do I just ignore the negative because it's volume and volume can't be negative? That feels a bit cheeky. I guess I'm allowed to do that. Actually, no. I'll just, yeah, this isn't the correct answer. This is the wrong way around. So I'll put the negative inside. And now it's the correct answer. I mean, I didn't write it quite the same, but yeah, it's the same. Okay, mark scheme. M1 for integration by parts using u equals x and dv by dx equals e to the minus 2x. A1 for this line. E1 for for what? E1 for this, even if you don't have plus c. M1 for product rule. What? Oh, that's or. That's or. Some crazy method that I don't recommend. Part 2, M1 for using integral of pi times y squared. A1 for realising that y squared is this. M1 for integrating, and it is dependent on, I can't see a star anywhere, so it's dependent on, must be dependent on this M1 here. And then E1 for getting the right answer, which was given to you, so E1 for coming to the correct answer in a valid way. Okay, that's the end of section A. I will see you back here in a moment for section B. Bye!